Picture this. You're building a React to-do list, the classic starting point for mastering interactive web apps. But as your app grows, every click, edit, and filter starts to slow down. Why? Because the way you store your data, using JavaScript arrays or objects, can make or break your app's speed, flexibility, and future scalability. Today, you'll discover how the right data structure underpins lightning-fast updates, seamless new features, and code that's easy to maintain, all without reaching for heavy external libraries. In this tutorial, you'll learn the core differences between arrays and objects for client-side storage in React. See how each affects real-world features like filtering, editing, and undo, and find out which approach scales best as your to-do list grows from a handful of tasks to hundreds or thousands. We'll break down the exact trade-offs, show you hands-on examples, and arm you with best practices so you can confidently architect your next dynamic list or complex UI. Whether you're aiming for peak performance, smooth user experience, or future-proof code, mastering this choice is essential. If you want to keep building smarter, faster React apps, make sure you subscribe now, because we're dedicated to delivering practical, up-to-date tutorials that help you grow as a developer with every video. When considering efficient client-side data storage for dynamic to-do lists in React, the foundational decision revolves around whether to use JavaScript arrays or objects. To understand this, imagine organizing your desk. If you lay out sticky notes in a row, numbered from left to right, and refer to each note by its position, you're using an array. If you instead pin each note to a corkboard, labeling each with a unique keyword like groceries or work, you're using an object. Arrays in JavaScript are ordered lists, with each item accessible by its numeric index. This order is guaranteed and manipulated easily. You can add new to-dos at the end, remove them from the middle, or change their order to suit filtering or drag-and-drop operations. This is why arrays are intuitive for representing to-do lists, where users expect their tasks to appear in the order they were entered or sorted. However, arrays have limitations. If you need to find a specific to-do by its unique ID, you must search through the entire list. This is a linear ON operation. For small lists, this is trivial, but as your app grows, this can introduce lag. Imagine looking for a specific sticky note among hundreds, reading each in turn until you find the right one. Objects, by contrast, serve as key value maps. Instead of hunting through a row of notes, objects let you leap directly to the one labeled groceries in a single step. This is because objects offer O1 access by key. When your to-do list grows, or when you need to frequently update, delete, or look up to-dos by their ID, objects offer a significant speed advantage. Yet, objects don't guarantee order. If you care about displaying tasks in a specific sequence, you'll need additional logic to track the order of keys or maintain a parallel array of IDs. The choice between arrays and objects therefore hinges on your application's needs. If maintaining order and easy iteration is your priority and your list is small or moderate in size, arrays provide a simple, readable solution. If you expect to frequently update or access to-dos by ID, or your list is large, objects deliver better performance and code clarity. For advanced scenarios, such as real-time reordering or filtering, combining both in a normalized hybrid model can deliver the best of both worlds, ensuring both order and fast lookups. In the context of React, your choice of data structure directly impacts how state changes propagate through the UI and how efficiently the DOM updates. React's rendering model is driven by state. When the state changes, React examines what's different and updates only the affected parts of the DOM. This process is called reconciliation. Imagine React as a meticulous librarian. Every time you hand in a list of books, your to-do items, the librarian checks which books have been added, removed, or changed, and updates the library shelves accordingly. The more organized your book list, the easier this process becomes. Arrays interact naturally with React's rendering system, especially when mapping over to-dos to generate components. However, React requires that each item in a list has a stable, unique key. Using array indices as keys is a common pitfall. If you remove or reorder items, React may get confused and accidentally update the wrong DOM elements, leading to subtle bugs. Assigning each to-do a unique ID and using it as the key allows React to track each item accurately. Objects, on the other hand, enable instant access and updates by ID. Updating a single to-do is straightforward and highly efficient. Just update the property with the matching key. But when rendering, you need to convert the object's values into an array, as React expects an iterable list. This extra step is minor, but slightly more verbose. For applications that need both order and fast updates, such as a to-do list with drag-and-drop reordering, a normalized hybrid approach excels. In this pattern, the state splits into two: an object mapping IDs to to-do items for fast lookup and updates, and an array of IDs for maintaining and manipulating order. When rendering, you map over the array of IDs and fetch each to-do from the object. This design mirrors how professional state libraries like Redux recommend structuring large, dynamic collections. Immutability is another crucial aspect. React depends on you to avoid mutating state directly. Instead, you should create new arrays or objects when updating state, ensuring that React notices the change and updates the UI. For arrays, use methods like map, filter, and spread syntax to produce new lists. For objects, clone the existing object and update only the affected property. This discipline keeps your application predictable and performant. Ultimately, your data structure choice shapes how naturally and efficiently your React components update, scale, and remain bug-free as your to-do list grows and evolves. In this example, we present the main application file for a React to-do list, demonstrating 3 different data storage strategies: array, object, and normalized hybrid. The user can select the strategy via a drop-down, and the corresponding implementation is rendered. This structure allows for direct comparison of update logic, state handling, and performance implications between the approaches. This file implements the basic to-do list using a simple array for storage. It demonstrates adding, toggling, and deleting to-dos, highlighting the strengths and limitations of array-based state for dynamic lists in React. Each to-do is an object with an ID, title, and completed status. This file showcases the object-based storage approach for React to-do lists. Todos are stored as keyed objects, enabling O1 access and updates by ID. For rendering, object.values is used to create an array of to-dos. This pattern is efficient for large lists and frequent updates, but does not preserve order without extra logic. This code implements the normalized hybrid approach, combining an object for fast lookup, BID, and an array for maintaining order, ALLIDS. This pattern is ideal for scalable, feature-rich to-do lists, enabling efficient updates and ordered rendering. This component provides the form to add new to-dos. It demonstrates controlled component usage in React and is shared across all to-do list implementations. The form ensures input is not empty before submission. The to-do list component receives an array of to-dos and renders each using Todo item. This file is agnostic to the underlying storage strategy, accepting a uniform prop interface. Todo item renders each individual to-do, displaying its title, completion status, and providing controls for toggling and deletion. It uses a checkbox input and visually indicates completion with a strike-through style. This utilities file provides functions for persisting to-dos to local storage and restoring them. It can be integrated with any of the storage approaches for client-side persistence. This configuration file defines project dependencies, scripts, and metadata required to build, test, and lint the React to-do application. It lists the essential React and testing libraries and is designed to work with Create React App. This is a unit test for the array-based to-do implementation. It demonstrates adding and toggling a to-do item, verifying that UI updates occur as expected. Similar tests can be written for the object and hybrid implementations. The application interface opens displaying the JS array mode with the heading To-Do List JS array clearly visible. An information panel labeled Array Mode is revealed, followed by an architecture diagram titled Array Storage to illustrate how data is structured in this mode. A new to-do is added by entering Learn React Arrays into the input labeled Add a new to-do and clicking the Add to-do button. The to-do appears in the list. Next, Implement Array CRUD is added in the same way, followed by Test Array Reordering. Each new to-do is appended to the visible list, providing immediate feedback. After a brief pause to observe the current list, the first to-do's checkbox is clicked, toggling its completion status. The to-do visually updates to show its completed state, typically with a strike-through. The second to-do in the list is then removed by clicking its associated Delete button. The to-do disappears from the list, and the remaining items shift accordingly. To demonstrate reordering, the last to-do item is dragged to the top of the list using a drag-and-drop gesture. The list visibly updates, reflecting the new order of to-dos. The Clear Completed button is clicked, removing any to-dos marked as completed from the list. The change is immediately reflected as completed items disappear. Next, the Object mode is selected by clicking the Object option. The interface updates to display To-Do List, Object, and reveals an information panel labeled Object Mode, along with an architecture diagram titled Object Map, explaining the data structure in use. A to-do titled Learn Object Map is added via the input and button, followed by Implement O1 Lookup. The to-dos appear instantly in the list. The first to-dos checkbox is clicked, toggling its completion status, visually updating the item. The second to-do is then deleted by clicking its Delete button and is removed from the list. The Clear Completed button is used again, removing any completed items from the display. The hybrid, normalized mode is then selected by clicking the corresponding option. The interface updates to To-Do List, Hybrid, and shows an information panel labeled Hybrid, Normalized Mode, with an architecture diagram titled Normalized Hybrid. 3 to-dos are added in sequence: Learn Normalization, Fast Lookup and Order, and Drag and Drop Support. Each is entered into the input and added via the button, appearing in the list in order. The first to-do is marked as completed by clicking its checkbox, updating its appearance. The second to-do is deleted using its Delete button and is removed from the list. To demonstrate ordering, the last to-do is dragged to the top, and the list updates to reflect this new order. The Clear Completed button is clicked once more to remove any completed to-dos. The changes are immediately shown. Finally, a detailed comparison table and an architecture diagram are revealed, summarizing the differences and behaviors of the array, object, and hybrid storage methods. The demonstration concludes with a final pause, allowing for review of the interface and its various storage strategies in action. You've now seen how the right data structure can transform your React to-do app, from smooth, instant updates with arrays to lightning-fast edits and flexible features using objects or hybrid normalization. By mastering these core patterns, you're not just building a better to-do list. You're laying the foundation for scalable, maintainable apps that are ready to handle real-world complexity. Imagine how much easier feature upgrades, bug fixes, and even team handoffs will become when your data storage is rock solid. If you want to shortcut months of trial and error and stay ahead with practical React skills, hit subscribe now. You'll get clear, hands-on examples and proven strategies that you can plug directly into your projects, accelerating your progress every week. Ready to build apps that feel as fast and robust as the best in the business? Make sure you're here for the next lesson.